All right, here we are back. We're still working on parabolas. So this is the second video about conic sections. Started parabolas last time. And last time we went in the direction that we started with the graph and we went to try and write the parabola. This time what we're going to do is we're going to start with um, a uh, an equation in not standard form, and we're going to try and figure out what the graph looks like and get the information. And at this point, all we've learned about are parabolas, so this will be a parabola question. This is section 11.2 in our textbook, question number 50. I'm going to do two problems, and we'll see how they work out. Okay, first off, notice this is an x squared type. Therefore, we know that this is the general standard form that we're shooting for. We're not quite sure yet if there's going to be a plus or a minus here. We'll find that out as we go along. So since you got the x squared type, it's either a open up or an open down type. If it's an open up type, you got a plus in front here. Open down type, you got the minus. So that's basically what should be going through our mind. Okay, so the method that we're going to use is completing the square. Notice you got the x terms here, the equal sign here. So what I'm going to do is I'm going to use the method of completing the square, and anything else I want over on the other side. So that's how I'm going to work this. And then whatever I put here, of course, since this is an equation, I got to balance it out by putting the same quantity here. So the rule is you take half the, well, that's if this is a 1 anyway. Half the coefficient of this term, half that's 3 and squared, you get a 9. So I'm going to be adding 9 to both sides because this is an equation. So on the left side, I get x plus 3 quantity squared. And on the right side, I get 4y plus 8. And as you can see, I've now got that in standard form. And this is our goal, to get this in standard form. Once you've got this in standard form, then you can pretty much get everything out of it. Okay, so let's go ahead and let's write down some of the facts here. First off, the vertex, -3, -2. Okay, and since this is a positive, you definitely know it's the concave up type. Okay, so this is 4p. So p equals a 1. All right, so we know all of these things. That's ugly. Okay, so p is a 1. We got the vertex. At this point, maybe it's worth, I guess we can make a quick sketch if you want. But so -3, -2 would be the vertex. So let's see, -3, -2. So I'm just going to do this 1, 2, 3, 1, 2. So the vertex is here. And it's a concave up type. So that means the focus, in this case, is going to be 1 unit up. So the focus, so this is the vertex. The focus would therefore be -3, -1. Okay. And well, I hesitate to draw this because I'm not quite sure exactly how it's going to go. So let's even forget here about the y-axis because I'm not sure exactly where that's going to be at this point. Okay, so I'm just going to go, this would be x is a 0, of course. So it's going to look like this. So the focus would be -3, -1. Okay, the directrix would be below. So this is a horizontal, so y equals, and it'd be p units down. So if the y values are -2, this would be y is -3. So this would be the directrix. I can't spell. Okay, it's going to look something like this. Okay, and through the focus, okay, we have the latus rectum, and the latus rectum has length 4p, which is a 4. So that means I'm actually going out two units. In each direction. So it should go through this point here, which looks like -1, -1. Okay. And the other endpoint of the latus rectum would be 2 units the other direction, so it looks like it would be -5, -1. Okay, so those would be the endpoints of the latus rectum. Okay, for the simple reason that has a length 4, so I'm going 2 units to the left of this focus, so it'd be -5, -1, and then 2 units to the right will be -1, -1. So a parabola is going to look a little bit like that. Okay, and I think that's about all we need to do here. And now let's look at another example, and we'll try that. And there's a take-home problem set, and you can see with all the little fiddling around here, I'm going to give you a nice grid on the problem set, so you don't have to worry about this too much. But you can see why it's a good idea to do these in pencil, because we do have to sort of be a little careful how we make our sketches. But as I said, I'm going to put this on and give you a beautiful grid to work with, and these are some of the things that you'll have to find. Okay? All right, so let us move on. I'm going to do now number 52 in the textbook, so I'm going to pause the video so I can clean up the board. Okay, and we're back. This is number 52, section 11.2 in the textbook. And once again, we're going from the equation to the graph, and it's going to be a parabola. When we get to later topics, of course, then we'll have to look at the pattern, decide parabola, ellipse, hyperbola, and so forth. But right now, we know it's a parabola. And by the way, if you're doing anything with a whiteboard, I just figured out Windex works great to clean these off. Okay, so this is clearly a y-squared type. All right, so I'm going to put down the general pattern. Let me do it here. Yeah, let me do it here for change. So it's y minus k, quantity squared, 4p x minus h. So this is going to be a left-right type, and depending on whether we get a plus or minus in here, we will be able to know if it's opening left or opening right. Okay, so once again, the idea is completing the square. So y squared minus 2y plus whatever equals 8x minus 1. And since this is an equation, whatever we add here to complete the square, we have to add here to maintain the balance. Okay, so clearly half of this is -1. -1 squared is 1, so I'm adding a 1. Okay, so this becomes y minus 1, the quantity squared. This, of course, is just 8x. So if you want to, you can think of it as 8x minus 0. All right, so this is our standard form version. And at this point, you can tell a lot of things. Well, first of all, it's a left-right type. Since this is a positive, we know it's going to be opening right. Okay, and we know just by sight that the vertex is at 0, 1. The x value first, the y value second. So this is your h, this is your k. Okay, so the vertex is 0, 1, and this is 4p. So 4p equals 8. That implies p equals 2. So that's going to be important for us as well. Okay, so let me see if we can sketch this out a little bit. Okay, we have 0, 1. Okay, that's our vertex, a point on the y-axis, and it's opening right. Okay, so the p is a 2, so if this is our vertex, our directrix, in this case would be a vertical line 2 units to the left. Okay, so this would be, well, let's see, this is x equals negative 2. Okay, so this is our directrix. Okay. I don't have the focus. Oh, yes, I do. Okay, so here's our vertex is 0, 1. Our directrix is x equals negative 2. And our focus is 2 units inside because this is opening right now. So our focus is going to be, well, 2 units over, it'd be 2 comma 1. So let me write this down. Focus would be 2 comma 1. Okay, so put that point there. And to get an idea of how quickly this is opening up, we would look at the length of the lattice rectum. So the lattice rectum is 4p. It's just a number in front there. So that's an 8. So that means that with length 8, we're going up 4 units. So if the focus here is 2 comma 1, up 4 would be 2 comma 5. And down 4 would be, well, let's say about 2 comma negative 3. So those points would be on the curve. So it's going to look something like this. Okay, this length here is your lattice, or this line segment is your lattice rectum. Here's your directrix, your focus, your vertex. Is there anything else we normally do? And that would be it. Okay, so this is something that you should be able to do. It goes pretty quickly, as fairly quickly as you can see. And on the take-home page, which I think I said was due Friday, yes. What it is I made a very nice grid for you. I made boxes. All you got to do is fill in the boxes with what's HK, what's the P, coordinates of the vertex, so forth and so on. The problems on the classwork page on Blackboard all fully worked out. So if you look at those, I don't think you'll have any problem. This is going to be a very easy confidence building problem set take home. We'll also do one with ellipses, one with hyperbolas, but this is going to be a real easy one. So it's going to be a nice way to relax after the vector one, which I think was kind of difficult. Okay, so see you in the next round.